How to remove a clutch? Okay, you are correct, Neil. Anyone else? Okay, it is one of the use case of cache patching, Harshit. So let me just tell you all once again what actually cache purging is. Actually, it is a removal of cache content from a CDN before its TTL expires, ensuring fresh content is delivered. Okay, so everyone clear with it? Okay, so can someone tell me what were the components involved? I'll give you one hint. It's one of the component is a origin server. Okay, correct. Eight servers. There are more. Okay, I will repeat my question, Neil. Question: what were the components involved in a CDN? Did you get the question, Neil?
Can I tell?
Yes, yes, please.
Origin server, then edge servers आणि cache system.
Are you sure about the last one?
Correct?
Sorry, can you repeat again?
It is correct. What is question? First name.
Okay, I will repeat my question once again. What were the components involved in a CDN?
Origin server,
I'll give one more. Okay, okay. Origin server. Okay,
then edge edge servers, DNS,
okay. DNS
load
what?
balancer. Then
See, there are
I
four
just
components. Okay, this is one of the hints. So three of them are answered: DNS, Edge, and Origin server. One more is missing, which was just answered previously. One of the popular cache key. No,
Cache systems.
no. What was a CD? What was Cloudflare? What is it? Correct. CDN provider. You're right, Tanvi. Yes, Harshit. You're also. So basically, the components are origin server, CDN provider, edge servers, and DNS routing system. Okay, so just a simple question. What is TTL? A very basic question. What is TTL? Time to level. Okay, can you define it?
Time limit for data.
Okay, can you be more precise? Yes, Neil and Ishwari. For specific data. Yes, you can also say in that way. So let me just tell you in a very simple terms. TTL, or that is time to live, is a mechanism in a computer network that limits how data, like packets or DNS records, can exist before discarding, preventing the endless loop and managing cache freshness. Okay, so everyone got it. So it's like a counter, or a timestamp that decreases as the data moves on until it hits the zero. Okay, so can someone tell me when not to use public CDNs?
Sensitive or confidential data.
Okay, you're right. One more. Strict compliance requirement. Yes, you are right. For the strict compliance requirement, also we are not using public CDNs. Okay, so can someone tell me what were the uses of CDN providers? Or actually, what are the CDN providers?
CDN is the content delivery network. It is company that delivers your website or application content to users faster, safer, using a global network of servers.
Okay, so let me just tell you all precisely that the function of Syrian provider is it provides global infrastructure first of all. Second of all, it maintains the edge servers. It handles routing, caching, and security. And also, it offers to like tools like DDoS protections, cache ruling, edge logic. Okay, so are we clear with it?
Yes.
Okay, so people, are you excited for the third episode?
Yes.
Okay, nice. So, just for the new viewers, I'd like to give overview of the podcast. So basically, the FOSS Files is a podcast of WLG, that is Walchan's Linux User Group, where we cover one major topic each year, and in this season we are covering CDN, that is Content Delivery Network. We uncover all the terms, topics, and ideas related to these topics. So, gear up everyone. We are going to start today's session. I request everyone to please stay attentive. You will definitely get great knowledge about CDN. I'd like to hand over the session to today's speaker, Rameshwari Satpathy and Vedant Tate Bhaiya. That was it from my side. I'll hand over the session to them. Thank you.
Hello everyone. Hello. Hola amigos. Am I audible?
Yes. Yes.
Okay.
You are.
Okay. So let's start. Okay. Now in the today's session, we will be learning about the routing secrets. In the previous sessions, you have learned about introduction to CN, CDN, and public CDN, right? Now today we will deep dive into the routing secrets. Okay. So let's start. Today we will be covering first the introduction of routing, then routing protocols. After that, Anycast routing and DNS based routing. Okay. Now let's start the topic routing. Before moving ahead, can you guys tell me, means when you open YouTube or Netflix on your mobile, then how the data travels from servers to your mobile? Anyone? No? Guys, be interactive. Okay, just tell me my screen is visible or not. Am I audible? Okay. So the answer is simply the routing. Okay. Now let's discuss what is routing. Okay. Now as we have discussed the topic, which is when you open your YouTube or Netflix on your mobile, then the data comes from the server, right? So the data travels from the source to destination, correct? Now for that, the data should choose the best path. Means routing is nothing but the process in which we find the best path for the data to travel. As data travels from source to destination, it should reach the destination very quickly. So for that, we choose the best path possible. Let's take one example. Suppose you are going to your college from your home, then or or any other destination, then what you will do, you will open the Google Map. Then what Google Map will do, Google Map will tell you the best possible path, means the path which is shortest and with less traffic, right? So that's it. Routing is nothing but the process of selecting the, or means finding the best path for the data to travel. Okay, now it's clear. What is routing, clear or not? You can just tell me by unmuting yourself or in the comment box. Okay, so let's start. Now, what is the importance of routing? Now, as you all know, there are millions of networks in the internet. So, suppose the data is traveling from source to destination and it is traveling millions of networks in between. So, that will uh, delete the data packet, right? So, that is not efficient. So for that, we should take the best path possible. We will not take the random paths. We have to choose the best possible path. Now what will this sorry because of this, what will this happen? So our websites will be fast, and the packet loss and network failure in between will not be there. Okay, so our websites will be fast as the data traveling from very fast by taking the best path. So our websites will be fast, right? That's it. This is routing is basically the process of finding the best path for the data packet. Clear? What is routing? Clear? Okay, so
Yes.
let's move forward. Okay, now we will see the DNS. You guys tell me what is DNS. Anyone? What is DNS? You can tell me full form or anything. What is DNS? Okay, domain name system. Okay. Now, what it does? You guys know it, right? What it does? Okay, so let's start. What is DNS? DNS is nothing but the domain name system. What it does, it basically translates your website names into the IP address. Okay, so what will happen when you type on the browser netflix.com, it will get converted to the IP address of the server, right? That's it. It is nothing but the system that translates the website names into IP address. Okay, don't get confused. Okay, now let's take one example. Suppose phone book. You have to call your friend. Then what you will do, you will search the friend's name in your phone book, right? Generally we don't know the numbers, we generally know the names, as names are easier to remember for humans. So for that, we will search the name and phone book will give the proper IP address, sorry, phone number of that user, right? Then you will call the him. Okay, so that's it. Now let's see how DNS works. When user types the website name onto the browser, then that will be sent name will be sent to the DNS resolver, and DNS resolver will ask the DNS server that what's the IP belonging to this name. Then that IP will be sent returned by the DNS server, and then browser will connect to your server. Okay, let's take this example. Here you are you are typing your website name. Okay, now that website name will be sent to the DNS resolver. DNS resolver will ask the DNS server that, hey, what's the IP of this what's the IP of the server belonging to this name. Then that IP address will be sent to the browser. Okay, that's it. Simple. It's easy, right? There is one important thing, means DNS can return the different IP addresses based on the user location and server load. Suppose let's take one example. Uh, let's take an example of Netflix. Netflix has servers in Mumbai and New York. Okay, then suppose one user which is in India, sorry, which is okay. Aniket, please mute your mic. Okay. Suppose let's take one example like Netflix has servers in Mumbai and New York, and one user from India tries to access the Netflix, then what DNS will do? DNS resolver, DNS will give the IP address of the Mumbai server. It will not give the New York. Means it will give the IP address of the server which is nearest to the user's location, so that the data will be traveled faster. Okay, clear? Means if user is in USA, then New York server address will be given to the user. Clear? What is DNS? Can you guys tell me what is DNS? What is DNS? Okay, that it just translates the names to the IP addresses. Correct. Now we have covered the topics routing and DNS. Now just revise quickly. What is routing? Anyone? You can unmute or type in the comment box. What is routing? Yes, best possible path. Okay, 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 okay. Not always the shortest path, but best possible path. Okay, okay. Now let's start with the next topic. Now, which is routing protocols. First of all, forgot about routing. Tell me what is protocols. What is the meaning of protocols? Rules. Correct, correct. Now, what is routing protocols? The rules that are used by the routers. Simple. The rules that are used by the routers is nothing but the routing protocols. Now, let's move forward. Now, as we have discussed, routing protocols is nothing but the rules that router uses for what? For sharing the information and deciding the best path. Clear? Nothing but the set of rules used by the routers for deciding the best path. Okay. Now, there are two major categories of routing protocols, which is first one is interior gateway protocol and second one is exterior gateway protocols. Now, let's see its classification. First classification is interior gateway protocol, in which we have two types. First is RIP, then OSPF, and second classification is exterior gateway protocol, in which we have one single type, which is BGP. Now, don't worry, we will discuss all this in detail in the further slides. Okay. For now, just remember we have these two classifications: interior gateway protocol and exterior gateway protocol. Okay. Okay. So now we will see one example where IGP is used and where EGP is used. First of all, this is an autonomous system. Now, what is autonomous system? Autonomous system is nothing but a large network which is under one organization. Okay. Suppose for example is India as a country, okay, or Jio, Airtel. We can take an example. Okay, the large network which comes under one organization is nothing but the system. Okay. Now, suppose you have to communicate between two. You have to communicate inside one autonomous system. Then you will use the IGP, interior gateway protocol. And if you have to communicate between two different autonomous systems, then you will use the EGP. Clear? As the name suggests here, interior means inside one autonomous system and exterior means between two autonomous systems. Clear? Type, which is RIP. Okay, so RIP, full form of RIP is, guess. RIP protocol, rest in peace. No. Okay. Full form of RIP is routing information protocol, not rest in peace. Okay. Now we will see what is it in detail. Okay, so let's move forward. RIP is nothing but a routing information protocol. Its full form is routing information protocol. And what it exactly is? First of all, let's understand that it is one of the oldest routing protocol. Now, it decides that which is the best path for the packet should be taken. right? What is the work of routing protocols? Set of rules used by the routers. Okay, and what is routing? Routing is the process of finding the best path. Let's revise. Okay, now what is RIP? RIP selects the route based on the hop. Okay, now we will discuss this theory later. Just take one example first of all. Now see this diagram. What RIP will do? Suppose RIP will have three routes: route 1, route 2, route 3. Then it will consider the hops, minimum hops. What is hops? Hops is nothing but the routers crossed. Can you see this routers? R4, R5, R3. Suppose this is the source and this is the destination. R1 is source and R3 is destination. Then you have three routes. If you go by route 1, then you have to cross the three routers R4, R5, R3. Then you will reach your destination. So here the hop count is 3. Here the hop count is 2. And here the hop count is 4. Now what RIP will do? RIP will select the path which has the minimum hops. Will select. Can you guys tell me? 2, right? Now, okay, you have understood this, right? Now let's go back and see. RIP selects the route based on the hop count. Hop count is nothing but the routers crossed. It will select the path which has the minimum number of hops. Okay, now let's take one example as hop as the bus. Okay, if there are two routes, route A and route B. If bus travels from route A, there are three stops, and bus travels from route B, there are only two stops. Then which route bus should take? It will take the second route. Okay. Now let's what is the core idea of the RIP? RIP selects the route based on the minimum hop count, and hop is nothing but the number of routers crossed, as we have discussed. Okay. Now path is the minimum hops is chosen. This is also we have discussed, right? Now it does not consider about speed or bandwidth. Means it will not consider about the speed and the in example we can take that it will not consider the quality of the road. Okay, it will just consider the stops in between. Okay. Okay, my screen is visible, right? Okay, now we will see how RIP works. Okay, so RIP uses the distance vector protocol. What is it? It is nothing but suppose there are these routers, right? So neighbor of R1 is R4 and R6. Okay, each router will have its routing table. Okay, now this routing table will be shared with their neighbors. Suppose R1 has neighbors R4 and R6, then R1 will share its routing table with R4 and R6. Okay, then similarly R4 and R6 will share its routing table with the R1. What will happen because of this? R1 will R1 will understand that R1 will get to know that there is a R5 as it was connected to the R4, and this routing information will be shared by the R4 to the R1. R1 will get to know R5 exists. Similarly, everyone will share their routing tables with the neighbors every 30 seconds. Now let's see. Each router maintains a routing table. Router shares its table with the neighbors. Correct. Now this process happens every 30 seconds, and the routers update the path based on the hop count. Now we have discussed what is this. What are we discussing here? RIP. What RIP will do? RIP considers only the minimum hops, means the stops in between the hops. Okay, the routers crossed. Now on that basis, it will select the best path. So that's it. Now this is understood, right? Everyone understood what is RIP? What is the metric of RIP? Minimum hops. Correct. Move to the second topic, which is second type. Okay, before that let's understand the limitation of RIP. Now as we discuss, it will not care about the speed and bandwidth. Means in general, it will not care about the condition of the road or speed. Okay, it will just consider the stops in between, and it is very slow to slow react to the failures. Means suppose if some router is not reachable, then this protocol will take more time to understand that okay, that is not reachable, we should remove it from the routing tables. Okay, and it is very long process. Now, sorry, it is slow process. Now, third point is it is not suitable for the large networks. Now, why it is not suitable for the large network? RIP protocol will allow only 15 hops in between. Okay, so it is not generally useful for large networks. It is useful for only small networks. In between, we can have at max 15 hops. Okay. Now, let's move to the second type, which is OSPF. We are considering interior gateway protocol, and we have discussed the first type, which is RIP, routing information protocol. Now we will see the second type, OSPF. Okay, OSPF is better. Now, what is OSPF? OSPF is open shortest path first. Okay, it is the modern and widely used protocol. Now here, what it does, it will consider the route based on the cost. What was happening in the RIP? We were considering about minimum hops, but here we will consider about the cost. Okay, now let's see what is cost. And another point is it is designed for the large and complex networks. Okay, now what is the core idea of OSPF? So OSPF selects the route based on the cost, not on the minimum hops. Okay, cost depends mainly on the bandwidth and speed. Okay, now let's take one example. Suppose here, see this diagram. Here, what RIP will do? RIP will select this path as this is the minimum. There are minimum stops in between, minimum hops. Okay, but OSPF will check the speed and means it will also check the condition of this road, condition of this route. Okay, there is traffic on it or not. So maybe if suppose let's take in general way, like this is highway and this is small road, then OSPF will maybe take this route of highway as there is only one stop extra, but this route is faster. So OSPF may choose this route. This is beneficial. Okay. Now cost depends mainly on the bandwidth. Okay. Now chooses the shortest path, shortest and fastest path. Okay. We have discussed this. It will choose the fastest path possible. Now it will not consider only the routers crossed in between. It will check the cost, which is the better way. Now let's see the working of OSPF. Are you guys with me? You have understood all the things, right? Now let's see the working of OSPF. Okay. OSPF works based on the link state routing. What is link state routing? Link state routing means every router will have the knowledge that how our network means how our map of the network looks like. Every router will have the map, complete map of the network. Okay. In the previous case, we were only have the knowledge of the neighbors, but here we have the complete map. Now, how it works? Let's see. So, routers discover neighbors using hello packets. What is hello packets? Means the routers will send the hello packets to every routers. Okay, hello request to every routers, so that the router will get to know that okay, this router exists in my network. Okay, this router exists. Similarly, so on. Okay. Now, routers exchange link statement advertisement. What is link statement advertisement? Link statement advertisement is nothing but the hello request sent by the routers. Okay. Now, because of that, the complete routers will be linked together and map will be generated. Now, this routers information will be stored in the link state database. Okay, each router builds one link state database, and there, what is link state database? Link state database is nothing but the map of the full network. Okay, understood. So now we have every route. Now every router knows how our network looks like. Every router has the map of the network. Okay. Now it uses the Dijkstra algorithm for the taking the shortest path. Now, uh, have you understood, right? What is OSPF and RIP? The main difference is just in RIP we consider the minimum hops. Here we consider the cost. Now let's see the structure of OSPF. This is the structure. How the structure looks like? These there are multiple areas. Okay, area 1, area 2, area 3. Okay, multiple areas. But the main rule is we cannot communicate directly from area 1 to area 2. We cannot have this path, this direct link. We have to go from the base area, which is backbone area. Always all the communication is between this base area. Okay, this helps in reducing the routing table size and failure. Okay, because of the backbone, it has the base area. All the paths, all the routing paths, if you have to communicate between these two, then you have to go from the base area. Okay, that is the simple rule. Okay, now understood. Okay, now we have covered interior gateway protocols. You guys understood? Let's revise. First, RIP, routing information protocol. Which metric is it uses? Minimum hops. Right, right. Okay. Now, what was the second one? OSPF. Okay. Okay. Now, what is the metric of OSPF? On what basis it selects the path? Fastest and shortest. Okay. Okay. Cost. Correct. RIP selects based on the minimum hops and OSPF selects based on the minimum cost. Now, let's move forward. Now we have covered the interior gateway protocols. Means suppose we have to communicate between two different autonomous systems. Then we will use this exterior gateway protocol, which is, and that type is BGP. Now we will see the BGP in detail. Okay. Now, what is BGP? BGP stands for Border Gateway Protocol. It is nothing but the EGP type of EGP we have discussed, right? There are two types: IGP, interior gateway protocol, and exterior gateway protocol. In exterior gateway protocol, this is the type BGP, border gateway protocol. Now it is used to route the traffic between autonomous systems. This is discussed. We have already discussed, right? If you have to communicate between two different autonomous systems, then we will use BGP. Now, there is a single global protocol used everywhere. This is the protocol BGP used all over the internet. Now, what is the core idea? What BGP does? BGP connects different networks and it routes based on the policies, not the shortest path. Okay, understood. Means in RIP there was minimum hops. In OSPF there was minimum cost. Here we have policies. Here we will not consider the shortest path. Here we will go with the policies. Hence the allowed path, not the shortest path. Okay. Now it controls how traffic enters and leaves the autonomous system. Means it has the capabilities to that one autonomous means one router can say that I have this path incoming, and it can broadcast. Then it can tell the other routers that there are only two paths. The third path is not third path is not visible. We can tell that power we have. So controls how traffic enters and leaves the autonomous system. You will better understood this in the next slides. Let's move forward. Now, how BGP works. Routers form BGP peering sessions. Means we cannot directly communicate. We have to connect the session. We have to make the sessions between them. Generally, there are two types. Okay, customer provider and peer to peer. Understood? Okay, I will take one example. That time you will understood everything. First of all, let's see that it uses the TCP protocol TCP and port number 179 for its communication. And how it works, it uses the path vector algorithm. Now, how path vector algorithm is different? Each router will have its AS path, means autonomous system path, complete path from the source to destination. Each router will have its knowledge. Because of this, we can remove the loop, means we can avoid the loops. Okay, as we each router knows complete path from the source to destination. So when next path, when there is a next router, then we will check that this router exists in our path or not. If exists, then this is a loop, so do not check it. So there is a strong mechanism here for avoiding the loops. As we have discussed, it maintains the asynchronous path to avoid the loops. Now it supports policy based routing. Okay, it is not always chooses the shortest path, it chooses the policy based. Now let's see, uh, take one example. Suppose this is India, this is one autonomous system, this is Russia, this is another autonomous system. Now from here, India to Russia, we have to send the data, or means send a parcel or something. Okay, now what is the direct shortest path? This, by China, by Pakistan. Okay, this is the direct path, but we can't take this path because of some policies or restrictions or agreements. We can't take this path. Generally there may be path from here to here. Okay, there is not direct path unless there is an agreement. Okay, have you understood? And each autonomous system will have its means it will control the incoming and outgoing, just like countries have its borders. Autonomous systems can control the incoming and outgoing traffic. Now now this is a network. Okay, let's see, let's take this example. Now these are autonomous systems 1 2 3. Wait, suppose we have to go from autonomous system 1 to autonomous system 8. Okay, this is source, this is destination. Now what is the path here? What will happen? We have to establish the connection session. Okay, so there are generally two types of session, which is customer provider and another is peer to peer. I will explain this clearly now. Now let's see, this is customer and this is provider. Let's take suppose customer one is a AS1 is now customer of AS2. Okay, AS1 is a customer of AS2, so all the routes of the AS1 will be shared to the AS2. Now similarly, AS2 is a customer of AS3, AS3 is a provider. Now all the routes of the AS2 will be shared to the AS3, similarly to the AS4 and AS5, and similarly AS5 is a customer of AS8 and all the routes will be shared to the AS8. So what is the path, best possible path here? This, right? Suppose we go this way, AS2 is a customer of AS6, but AS6 is not the customer of AS7, so we can't go from this side. Okay, so we have only one path which is longer than this. We can take this path also, but this is not a customer of AS7, so that's why this is also shortest path, but we can't take this because of policies. Understood? Now there is one way to use this path. What is that way? This, we can make the peers, we can make the AS6 and AS7 as peer. Okay, establish the peering connection. Suppose let's take one example. Uh, this is Vi and this is Airtel. Then we must have agreement in between. So now we have developed agreement, made the agreement between that. Okay, you use my routes and I will use your routes for mutual benefit. Okay, now what will happen? We will not take this path, we will take this path which is shortest. And because we have made the agreement in between, we have policies. Because of policies we were not able to use this path, but now we can use this path. So this was it. Now, have you guys understood what is BGP? Any doubt? Okay, if we have to communicate between one autonomous system, inside one autonomous system, there are two types, which is RIP and OSPF. And if we have to communicate between two different autonomous systems, then there is BGP. Okay, understood. And BGP works on what? Please write in the comment or tell me. BGP works on the hot matrix, minimum hops, minimum cost, or policy policy. Okay, that means the allowed path. That may be not the shortest path possible, but it is allowed only. Okay, now you guys understood that all the things. In any topic you have any doubt, then please raise your hands. Everything is clear? Understood? Okay. In the last, just tell me what is routing. Okay, routing is the best possible path. Okay. Now okay. Okay, every concept is clear, right? No doubts? Okay. Now, that's it from my side. Hope you have enjoyed the session and understood everything. Now, the next topic will be covered by Rameshwari. Thank you.
Hello, am I audible? So now we have learned a lot of things about routing, DNS, PGP, OSPF, etc. Now let's just dive into routing, and there are two major types of routing that we will be covering. First is anycast routing, and then there is a DNS routing. So, has anyone heard about anycast routing, or does anyone know what does unicast means? Okay, share with single entity. Or in networking terms, we can say one IP and one server. So in anycast routing, next slide. Previous slide. So, uh, Anycast routing is the routing technique where the same IP address is advertised by multiple server located in different geographical regions. So let's just take an example of call center. Now you are in Sangli and you have to call the national helpline number, which is 112. So if you are in Sangli, you will be definitely connected to the Sangli police. And if you are in Pune, you will be connected in Pune police. Even if you came from Pune to Sangli for some reason, you will be connected for Sangli with Sangli police, right? So you don't have the right to choose your call center. The network, the ISPs does for you, right? And the whole country has the same national helpline number, and the servers will choose you to the best one. As for example, if you are in Sangli, you'll be connected to the Sangli, and if you are in Pune, you'll be connected to the Pune. So similarly, anycast routing is a network routing technique where the same IP address is there for multiple servers which are located in different geographical locations, and the client is routed to the nearest or the best server based on the different policies and different conditions that we have. And these decisions made by the BGP, that is, can anyone put in the chat box what is the full form of BGP that we have learned a few minutes ago? Gateway protocol. So border gateway protocol handles the every decision that how does the which router is connected to the which network, and anycast routing is commonly used in CDNs, DNS, and DDoS protection. So you must be wondering, right? Next slide. Why we need anycast routing? Why just we simply have one single server with one IP, and that's hosting everywhere? Can anyone answer why we don't use a single server? Latency, right? For load balancing, okay. Single point failure, yep. So there are lots of reasons that we don't use a single server, and there might be another question arising for you that what why don't we use a different IP addresses for different server instead of using one single IP for one single server? So now, if every user across the world had to connect to a single server, latency would be extremely high, and anycast exists. Next slide. So the latency would be extremely high, and due to Anycast, the availability of the server is increased because there's no single point of failure, and it can handle massive global traffic, and it also supports the automatic failover. And this is the reason that we don't use one single server. And Anycast is needed because it allows the server selection and failover to be handled by Internet's distributed routing system, that is BGP. So instead of relying on fragile centralized application level decisions using different IP addresses, we use Anycast so that different servers are handled whenever there is a traffic, whenever there is a fail, there is a one server lags, the BGP handles everything instead of relying on application level decisions for the different IP addresses and different servers. Now, next slide. Hello. Okay. So what does the failover in Anycast? What does the failover in Anycast means? Means if the server fails, then the route the which is leading to that particular server is withdrawn, and BGP updates the routing table, and when the next nearest net edge will handle the traffic, and there is no need of manual intervention. Means you don't have to do, as a server handler, you don't have to do anything. The BGP will handle itself everything. So that's one of the key advantages using the Anycast. And how does the BGP selects the route? So there is different policies for selecting the route. It as it is not based on the physical distance, it is based on the network distance, which considers the lowest network hops that we talked earlier. That is the number of routers is required for completing the path. So it also chooses the shortest AS path. Can anyone tell me what is AS path? Can see people typing in the chat. Autonomous system. Okay. So BGP selects the shortest AS path for optimal performance and for to reduce the latency. Now let's just take a look at the example, how it works in actual environment, how it fits in actual environment. So now suppose you are in Sangli. Now you hit the example.com on your browser, and DNS resolver will give you the IP address for that particular website. But that's the front face that we are seeing. The actual magic happens behind the scenes. So what happens is, there are servers in Kyoto, Mumbai, and New York. Now the client, that is your phone, tells to the router that I need to send the packet to the particular IP address. Then the router will take a look at the routing table. So this is the routing table that we have, and it is according to the routing table we will get the best the shortest AS path server. So that will be connected to the shortest one, and eventually getting the best route. And yeah, we are connected to the Mumbai server, and we will be usually getting the packets from there. Now you might be getting like a lot of questions, like what if this happens and what if that. So let's just take example that now you are in China, and you again hit the same website and you get the IP. But now your servers are in India, Russia, and US. And now in our case, India's server and Russia's server are at the same distance. So in our case, the Russia's has the shortest AS path. So that's the point where we are trying to show that it does not matter what is the physical distance between the server and the client. The network distance matters the most, irrespective of the physical distance. So in this case, chosen as the server. Yeah, we are connected to the Russia server. Now failures are everywhere, right? So what if in a previous example the Mumbai server fails? So the Mumbai server fails, the routing table will again come in the action, and now the route to the Mumbai server would be withdrawn, and the next best route, that is in this case the Kyoto, will be chosen. Now the server will be connected to the Sangli, the Kyoto, and this entire process, the updation of routing table, the connection to the GP, requires the times between seconds and minutes. It don't take that much amount of time. Now, advantages of Anycast, like as we discussed before, it has the lowest latency. It provides a low latency, and it has a built-in fault tolerance, which means it supports the automatic failover, and it is globally scalable. Means you can host your servers at different locations, irrespective of their physical distance. Now, let's look at the limitations of Anycast. So first, there is a issue of session persistence. Like any cast can struggle with maintaining persisting sessions, which can challenge for the application that requires continuous connections. Then there is it is not ideal for stateful applications. Can anyone tell me what is stateful applications? Have you ever heard about stateful and stateless applications? Okay, so see Neil is typing. Okay, so what does a stateless application means? That you have a server and client, right? So, if we talk in basic language, that the sum of the data is on the server side, and you need the server you need the server to run continuously in stateful applications. And what happens in stateless application, that you pass the state to the client side and it stores in its cache and local storage. So in this case you don't need a continuous application. So that's why any cast is not ideal for stateful applications, since stateful application need to maintain the state of interaction, and any cast has a nature of redirecting traffic to the different servers, so that can disrupt this that can cause errors in the states. Now, TCP connections may break. So, we have talked about TCP and UDP in the first session as well, and we talked about you must have learned it in the computer networking as well. So, can anyone tell me what is TCP and UDP? PC transmission control protocol for more reliable communication, right? So usually the TCP packets have contain more data, and it is used for stronger connection, right? So TCP connections may break because any cast routes traffic, which can cause the connections to drop unexpectedly. So suppose if we have to upload a larger file, it's anycast routing would not be a great choice for this condition. And needs for careful BGP design. So all these things are handled by BGP, right? So BGP designing is the crucial part, and it becomes complicated since we have to consider all those limitations. So eventually, it's a hectic process, and it is a very crucial process to design a better level BGP, so our connections won't be breaking and our traffic routing would be easier. Now, DNS based routing. So, as we earlier discussed in the session, DNS is a domain name system, right? Now, what is DNS based routing? It's a traffic steering technique where DNS system decides which server IP address to return for a given domain name. So, in this case, in case of DNS, we have multiple IP addresses working under the same domain name. Unlike in any cast, there are multiple servers having the same IP address. In case of DNS-based routing, we have different servers different servers which are having different IP addresses but working under the same domain name. So you might be wondering, in case of Anycast, we said that it is fragile and it is not enough to build different IP addresses and different servers. So what happen is that provides us, like DNS routing uses different IP addresses because it needs explicit policy driven control. Like while Anycast intentionally gives up the control to the network for speed and resilience, means in DNS you get more accessibility and more authorization over your system compared to the Anycast. So if you are hoping for if that's why different IPs are chosen. Now let's just take a look at the example, like how does the we get the IP address from the DNS. So what happens is there are multiple servers, and for I am sitting in Sangli and I need to get the IP address for that particular domain name that I entered, because computer won't understand what I entered as a domain name, but it has to understand the IP. But there are multiple IPs. I had to choose the optimal one and the correct one. So what happens is that if you enter the xyz.com in your browser will first check the DNS cache. So do you know about cache hit and cache miss? If you can answer by while unmuting the mic, or you can answer in the chat box as well. Yeah, cache hit is record is found, right? So what happens is the IP address from the previous request will be stored in DNS cache, and if it's found, then it will be a cache hit, so that we got the IP address. No need to go to the resolver, and now we have now we. If there is no IP address present, then the cache miss will occur, and we'll go to the resolver. Now, in this case, resolver is like a guide that we have for which helps us for finding the right IP address. So that's how the main action begins. Now the main resolver does everything for us. Like now, there are different servers that which comes in action. That is root server, TLD servers, and authoritative servers. So suppose you are in a bank, and now you enter the bank, you will first ask the security guard where is the cash withdrawing department. He will locate you to the cash withdrawing department, and you ask a person there where is the actual cash will be withdrawn. Then the person will tell you that there is the actual at cabin number 13 the actual cash is withdrawn. You go to the cabin number 13, and that's where you get the actual cache. So in this case, first the resolver asks that where is xyz.com. Then the root server responds that I don't know what is the IP address of xyz.com, but you can ask the .com TLD server. So the resolver now goes to the TLD server. TLD server is top level domain server. So resolver asks where is xyz.com. So TLD responds that I don't know where is TLD server, but I can tell you that it is under the authoritative DNS server, which is ns1.xyz.net. Now, the authoritative DNS will respond the IP address along with the TTL. So TTL is time to live, right? So before moving to the TTL, so now from the authoritative DNS we got the IP address, but before that authoritative DNS considers some parameters, that what is the region of the resolver, what is the latency matrices, there are different routing policies, and the edge server load. So after considering these facts, the some IP would be returned along with the TTL. So why the TTL is required? That suppose you might be wondering, if our server is dead and if the TTL is expiration, like if our server is dead at 10 seconds and TTL expire at 60 seconds, you would be hitting a request on dead server. But that's also one drawback of TTL. But the thing is that because of TTL, you don't have to repeatedly make request to the resolver for finding the IP address. That's why TTL is important in this case. Now let's just look what does the actual things happens. So recursive resolver, which acts as behalf of the client, and it caches the DNS responses and on your device, and it eventually reduces the lookup time. There are DNS resolvers exist like Google's. If you hit the 8888 IP address on the website, you will get the Google's DNS resolver. It is like it is called recursive resolver because it queries to the different server until it reaches the final until it gets the final IP address. Just like you have seen into recursion tree, right? It goes down till it gets to the base condition and then it returns back. Now, root DNS server. So root DNS server is the major major thing in our entire infrastructure of DNS routing. It is on the top of the DNS hierarchy, and there are major 13 logical root servers which are globally distributed, and there are 504 physical servers, but there are mainly there are 13 logical. And remember that root servers are fundamental because they ensures that every domain name query begins on the right path. So it directs the resolver to the TLD servers, which is a crucial point. Then we have TLD servers. That is, so these are the map of where are the 13 logical root servers present and 504 physical servers. If you want to deep dive into how does the root DNS servers has this different physical servers, etc., you can definitely look up. It's based on one of the topic that we have discussed recently. Now TLD servers. So TLD servers are like they manage the domains like .com, .org, etc., and they direct the traffic to the authoritative servers, which are like the next stop for our DNS journey. Now, the key function of TLD servers is like top level delegation. This means they guide the queries to the right authoritative server for specific domains. This means they guide the query. Think of them as like a controllers ensuring the queries that reach proper destination efficiently. Now, so you might be if you ever went to a DNS buying domain buying website, you must have seen that some of the domains like .com or .in are available so cheaply, right? Then there are some domains that like .so or AI nowadays it's training. It's quite expensive. So in this case, you have to set a server for each domain separately. So for not well popular and for not highly used domains, these are expensive like .so. So that's why, and .com are quite cheap because it is widely used and there are already present servers for handling those requests made on that particular domains. Now the main endpoint or the base condition in our DNS journey is that the authoritative DNS servers. It is like the final source of truth, we can say. The authoritative DNS servers hold the final IP, hold the records of domain name that convert into IP addresses at the end, and these authoritative DNS can apply the routing logic, and it is controlled by domain owner. So you can actually apply the you can actually control all those domain, and it eventually makes your it eventually gets your control on the overall your system. So it's been quite a lot of things happened, right? So let's just take a quick look at how does everything happens. So first we have a client. Suppose you are you are on the browser and you hit google.com or xyz.com. Then the recursive resolver come in action. It will ask first the root server. Root server will tell that ask for .com. Then the TLD will come in action. So TLD So the TLD will now the TLD will come in action. So TLD will tell that go to the particular this authoritative server for getting the IP, and the IP will be returned and the client will be connected. So now there are if you have any doubt up till this part, you can ask in the chat box. Okay, so then we have different techniques and methods for DNS routing. So first is geo-based routing. So the main idea here is to find out the resolver location, and after finding the resolver location, the DNS will return the nearest data center. And why it is important? Because it can actually improve the performance by reducing the distance data must travel, and that's why geo-based routing is used. Then we have load-based DNS routing. So it is used to avoid the overloaded servers by distributing traffic more efficiently. And to do so, we had to health check the servers to check if the server is capable of handling request, so we can eventually improve the reliability of the network. So if the server is actually capable, we will send a request to that particular server. So the um, overall failing of the server would be lesser. If the server is not capable, we won't be sending that many requests to that server. So this we can use load-based routing and the geo-based routing with together, so that have a performance-based and the reliable server at the same time. Now latency-based DNS routing. It is in this method we check the time taken for the data to travel between the servers and users, and it selects the fastest route available. And the main goal here is to request the server that with the lowest network latency, which ensures that the user experience is high, means like you get a better performance and the latency is not that much. And we because of this, we need the continuous monitoring, because it is based on real time, and the system is allowed to choose the optimal path based on the real time network conditions. Now there are some websites that let you host your DNS, and some of them are listed down here. Let's just take a quick look at it. So first up is Bind. It is one of the oldest and widely used DNS software. It is known for its flexibility. Then we have a Power DNS, which is great for if you are looking for the performance. Power DNS is for you. Then Not DNS, which is another option for the fast performance, and it is great choice for those who need efficiency without any lot of overhead. Now there is a core DNS, which is like highly modular, and it is oftenly used in cloud native environments, and it is particularly suited for integrating with Kubernetes. And lastly, we have Unbound, which is focused for security and privacy. Now you must be like if you recall all those 3 episodes, you must be seeing that some of how the things are connected for getting you the best experience. If not, don't worry, we will be having a quick overview of all those 3 sessions that we have talked earlier. Now let's just recall. First is our journey. Like our journey has been quite adventurous, right? So first in episode 1, we started with absolute basics like what our networking is, how devices communicate, what are IP addresses, protocols, routers, and TCP, UDP, etc. Then in episode 2, we asked about How does this work at internet scale? So that's where DNS actually came in action. So like edge servers, origin servers, caching, TTLs, etc. Then in today's episode, we went deeper and actually looked at routing protocols, that is Anycast and DNS based routing. So in episode 1, we learned that every request travels through the routers using IP addresses and protocols like TCP and HTTP. Now we also realize the limitation that networks don't remove distance. If a website is hosted in one country and users spread across the world, the latency is unavoidable. That's exactly problem CDN solve, which introduced in episode 1, and then we covered it in episode 2 as well. So instead of changing the networking rules, CDNs works with them. They replicate the content, deploy the edge servers across the region, and ensures that every user reach the nearest copy. So like CDNs are like a smart layer that is built on top of networking fundamentals. And we talked about once the content is closer the users, next is performance. That's where the caching come into action. Now we saw that edge server stores the cached copies, cache hits avoid the unnecessary origin request, and cache miss fetch the data and store it for the future users. Then we also looked about cache purging. What How does the unused cache are deleted, and how does the TTLs works? So that's how the caching turns the distributed system into fast and scalable ones. And that's come here. Here's the point where the most invisible but crucial part is that how traffic knows where to go. Now we understood the routing protocols like RIP chose the path based on the hop counts. OSPF considers the bandwidth and the cost. And BGP operates at internet scale between the autonomous systems. Now, using BGP and CDNs, using BGP, CDNs using BGP, the Anycast routing is used so that our CDN are implemented in the real life scale, where the same IP address is advertised from multiple locations, and the network automatically routes the user to the nearest or the best server. And at the same time, CDNs also rely on a DNS based routing. So how does that happen? Is that in this case, DNS based routing helps us to decide to which IP address to return to based on the geography, based on load, based on latency. And so that's how the routing makes the overall CDN adaptive and global. So here comes the one entire system. Like when we put everything together, we can see the complete system. That networking provides the communication rules, then CDN optimize the content delivery, caching ensures the speed and scalability, the routing and DNS makes the decisions for adapting network, and Anycast ensures the availability and failover. So that's how the this is why you might be wondering that how does the like Hotstar works, how does the Netflix got the content so fast delivered, or even the lives from different locations are so instantaneous that the latency is bare minimum. This is the end everything that we talked about till this session, and we'll be learning for different parts in further session as well. So if you have any thank you for being the part of the session, and let's just start. If you have any questions, you can ask in the chat box.
Okay, so in for the failover, in case of Ncast routing, the Ncast itself is failover mechanism. Like for example, if you're sitting in Sangli and the your edge server is located in uh, Mumbai. So for suppose if that server fails, what would happen in case of BGP? So now if that server fails, now that server will not be available to the internet, right? So how exactly this will happen is that wherever that BGP edge server is, sorry, wherever the Mumbai server is, the surrounding routers will know that yes, this server is down now. So basically, they will remove that edge server from their routing tables. Right. Now, once they have removed them from their routing tables, they will pass on those routes to their own providers. Right. So, see, and then they will pass to their own providers. So, this is how the entire record will propagate. And as a consequence, because the edge server, which was in Mumbai, uh, failed, you now need another IP address with that same. Sorry, you need that another edge server with the same IP address. So consequently, this is the magic of BGP that somehow the IP of the nearest edge server will automatically reach to your uh, nearest router or your ISP basically. Because suppose if your Mumbai edge server failed, automatically your router will know. It will obviously take some time. Suppose if the nearest server is located in Delhi, so yes, the automatically your router will know that Delhi server is there for me now. Now, if once again, if the Mumbai server comes up, BGP will automatically take the control. It will now see that the less autonomous system, because see, the BGP works on the basis of autonomous system hops. Now, if you're sitting in Sangli, you will need less autonomous system hops as compared to like if you have to reach Delhi. So basically, in that case, the nearby routers will see that with the same IP address, we have a new edge server. So they will basically remove the Delhi edge server from their entry and again put in the Mumbai edge server. So, and this is how your Mumbai edge server entry will again come to you. So you can see that BGP obviously takes some time to update its routing table, but it eventually does. And like this is how failover works in case of any cast routing. No management is whatsoever required by anyone. The network is actually self-healing in nature. If it sees problem, it fixes it automatically. No one has to intervene. That is why Anycast is like very popular for cloud service providers. Cloudflare mainly uses Anycast for its services. Any more doubts?
Okay, so I think there are no more doubts. So I think we can conclude this session. So basically, thank you for attending this FOSS File session 3 and stay tuned for upcoming sessions. Thank you, everyone.